In today's video, I'm going to teach you how to integrate by parts. So maybe you've already seen this crazy looking integration by parts formula before, but you're not really sure where it even came from or how to apply it to integrate something. Well, this formula actually comes from the product rule for differentiation, which you might have already heard of, but let me just refresh your memory. When you're trying to differentiate something that looks like a product of two functions of x, so u is a function of x and v is a function of x, the derivative equals u times dv by dx, where dv by dx is a tiny change in v with respect to x, plus v times du by dx, which is a tiny change in u with respect to x. If I rearrange this product rule, I can actually arrive at the integration by parts formula. So I'm just going to take away v times du by dx from both sides of the equation. And I'll have this on the left-hand side, and on the right-hand side, I'll just be left with this term. Now I'm going to switch the sides of the equation around, so I'm going to bring this over to the left and write all of this on the right. Now what I'm going to do is I'm going to integrate this equation through. So I'm going to integrate this side and integrate each term on the other side. What we can see is we have something that almost looks like the integration by parts formula. This term right here, the one I've highlighted in pink, this is actually just equal to uv, because differentiating something and then integrating it just leaves your original function unchanged. So all of this just equals u times v. So I'm going to substitute u times v for that term. We can see that what we have now is actually just the integration by parts formula. Now, how do you apply this formula to actually integrate something? Well, I'm going to walk you through an example so that you kind of get the hang of how to apply this formula. Let's say we're trying to integrate x cos x dx. What I need to do, my first step, is I need to put this integral in the form of u times dv by dx, because that is what we have on the left-hand side of our integration by parts formula. So I'm going to set u equal to x and dv by dx as cos x. Now if you look at our formula, the right-hand side has u, v, and du by dx. We already have u, we've just picked that to be x, but we don't have v and we don't have du by dx, so I'm going to evaluate those. So if u is x, then du by dx will just be x differentiated, which is 1. And if dv by dx is cos x, then v will just be the integral of cos x, which is sin x. Now we can use these values and substitute them into our integration by parts formula. So our u is x. Oops. Our u is x, and dv by dx is cos x. So this is just the expression we were trying to integrate, x cos x. This is equal to u times v. U is x, v is sine x, minus v, which is sine x, times du by dx, which is just 1. And we're integrating with respect to x. Now, I'm going to evaluate this integral, the second term. So the integral of sine x is negative cos x, which just simplifies to x sine x plus cos x, which is the answer. So hopefully that gave you an idea of how to apply the integration by parts formula. You need to pick something to be u and something to be dv by dx, and then find du by dx and v, and substitute these into the right-hand side of the formula. Let me walk you through another example. Let's say we're trying to integrate x squared ln x dx. For this integral, I'm going to pick u to be ln x and dv by dx to be x squared. Now you may be wondering why I made this choice. How do we actually decide what to set as u and what to set as dv by dx? Well, we know that we're going to have to calculate du by dx and v. So whatever we pick as our u needs to be something that's kind of easy to differentiate, and our dv by dx should be something that looks kind of simple when we integrate it. Typically, if the expression has a ln term, then we choose u to be ln x, because differentiating this is quite easy. It's just 1 over x. If our expression has something like x to the n times a trig function, for example, like x squared times sine x, then we choose u as x squared. There is an acronym that you might find useful to sort of see the hierarchy of what you should pick as u. L stands for log, I is inverse trig, so functions like arcsine, arccos. A is algebraic expressions, so anything like x squared or just x to the n. T is trig, so sine, cos, tan. And E is exponentials, so for example e to the x. So if you see a function that has logs in it, pick that to be your u. Let's get back to our example. So dv by dx is x squared, so our v, I'm going to find that by integrating. It will be x cubed over 3. Now I'm going to substitute into the integration by parts formula again. This equals u times v, so ln x times x cubed over 3 minus the integral of v times du by dx. So v is x cubed over 3, and du by dx is 1 over x. We're integrating with respect to x. I'm going to simplify this now. This becomes x squared over 3 dx. Integrating this term will give me x cubed over 9 plus c. And this is our final answer. Hopefully you found this video helpful and now you understand how to integrate by parts. Thanks for watching.